Okay, part 3. You made it this far. Thank you for watching. All right. Angle 1 is congruent to angle 2. I also know that Q is the midpoint of PR. Well, that doesn't really tell me anything directly, but it tells me this is true. Let me write that separately for step 2. It tells me that QR is congruent to QP. Name of that is because it's a midpoint. I don't even know where I'm going yet with this proof, but I know that's going to be in there because just saying it's a midpoint isn't really worth anything until you do that. And I know QT is parallel to RS. Okay. So in this triangle I'm trying to prove here, the only two triangles you see, I have a side and an angle already. So there's a side, there's an angle. So this congruent statement may be part of angle, angle, side, or angle, side, angle. Actually, I should probably write this the other way then. It could be angle, angle, side. Whoa, come on. Let me move the S. I can't just move the... Oh, I can't, really? What? The older version of this software was better. There's an angle and there's a side. I should write it that way because it could be AAS, could be SAS, could be ASA. Okay, and there's an angle and a side listed already, so I've already got it. Now, the only thing I haven't used here, so sort of I've used that, I've used this in my angle and my side. I haven't used this fact for anything. I used that to get this. So what's left here is the QT being parallel to RS. Parallel lines, and people always have this make this mistake in my classes. They see this little mark here and they go, okay, I got to get these sides congruent, or this kind of means that these sides are congruent because it's a little mark in the middle of the side like this, and they think, oh, that means QT and RS are going to be congruent, or they are already, or something crazy like that. No, parallel is not really good for showing length equal, but it is really good for showing when angles are equal, because parallel is all about direction, and it's about sort of, when all those different kinds of angles we got congruent when we had parallel lines, like AIA and corresponding. Namely, I got corresponding angles right here. That little angle is corresponding with that little angle, which is exactly what I need to complete ASA for this step. So I got to say why those angles are congruent, then I'll have that for step 4. Those are congruent. Angle at Q, don't just say angle Q because there's too many angles at Q, so you got to be specific. But you can just say R. There's only one angle at R, so that's fine. They are corresponding angles, and they're congruent because the parallel lines tell me so that they are corresponding angles are congruent. That's a postulate, 10 or 11. Okay, that's it for that one. Okay, JKLM is a parallelogram. Oh, that's a huge fact. Write equations and find values of x and y. Oh yeah, this is an awesome little system. First of all, there's x and y involved in sides, and there's x and y involved in angles. So the sides equation is that, gosh, do I have enough room for this? Is that 4y plus 5 is equal to x plus 7, because those are opposite sides of a parallelogram. Now here with the angles, this 2x minus 6 and this 100 minus 3y, they're not equal. They are same side interior, so they add to 180. 100 minus 3y plus 2x minus 6 is 180. So now I have this situation where I've got two separate equations that both have x's and y's in them that have to be solved at the same time to give me x and y. Let me pause and do some algebra magic. I'm going to rewrite each equation in a nicer format, but it takes forever, so I'll pause. Okay, I left the equations in the same order. That's the first equation just solved into sort of standard form. I subtracted 4y on both sides. I subtracted 5 on both sides. Here I combined like terms and left the x's and y's on one side, and I took the 100 and the negative 6 to the other side like that. All right, this isn't really nice to solve yet, but if I take the top equation and multiply it by 2, I'll get 2x minus 8y equals 4, and then if I subtract these, the x's all go away, and I get 3 minus negative 8, and 86, really? 86 minus negative 4, is that true? Oh, you know what? X minus 4y, 5 minus 7, wait a minute, I think I did something wrong. Yeah, I'm doing x minus 4y, that's on this side. The 7 should be subtracted from the 5 on both sides, so this should have been negative 2, so this should have been negative 4. So this should have been 86 minus negative 4 is positive. Yes, this really was negative 4. This should have been positive 90. I knew something was going to look wrong, so that tells me that y is 18. Phew, that took a long time. Then I put that back into some equation somewhere. Now that I know I fixed this negative 2, I'm going to do this one because it doesn't look quite so nasty. X minus 4 of those 18s is supposed to be negative 2. So 4 times 18 is 72. X minus 72. Okay, gosh, I remember. X minus 72 is supposed to equal negative 2. So add 72 to both sides. X better be 70. Okay, so X is 70. Y is 18. Find the perimeter. Oh my gosh. Okay, each side here is... Well, there's a 112. Oh, good. I was going, how am I going to find that? All right, 112. And so that's 112. The x plus 7 is simply 77. So we're looking at 77 plus 112 plus another copy of those. And I add those all up. And I believe I get 378. Yowza, that's a lot of math. Okay, a lot of algebra, really. There's math all over this one, but there's a lot of numbers and algebra in that. All right, mark this stuff. Oh gosh, am I gonna have room here? I think this is kind of long. I'm not sure if I have room. All right, AG is congruent to FC. Ooh, I smell angle addition. I'm guessing AF is eventually gonna be congruent to GC, but we'll see. AB is this one. Is congruent to BC. Ooh, look, isosceles triangle. That's kind of nice. And angle D is congruent to angle E. All right, we're trying to prove that. So step, save myself some room here. That's the given stuff. That's given. I'm trying to prove, and I hope I have enough room, that DG is congruent to EF. Well, this looks like a CP-CTC kind of thing to me. That DG and EF are going to be parts of bigger triangles. Namely, the only triangle up here that the DG is part of is DGC. And the only, well, that would have to be congruent to DG, so you'd have to go EFA. And why is that? I don't know. Do I have any of that stuff yet? Actually, these sides that I already have are not part of it. I guess I have an angle, don't I? I have angle D and angle E. I have that to go on. But just like I said, I think we'll be able to say that side is congruent to that side. Let's get that out of the way. Oh, and then the other part, I guess, will be this angle down here. I can do itbat for this. All right, it bets faster. Let's say angle A is congruent to angle C. I like to call that itbat. Some teachers call it ITT angles. Some people call it theorem 4-1. Can I just say 4-1? Am I really sure it's 4-1? I'm accidentally memorizing this book. All right, so there's an angle, there's another angle. Do I have the side between them when I get this one? Angle, no, it's angle, side, actually. Okay, that side in between them, am I jumping around enough for you? Is going to be AF. So the step right here is going to be AF. It'll be equal to GC. Getting AF to equal GC is kind of a pain. I'll be able to say something like AG. See, I knew AB was equal to... No, AG was equal to FC. I'm going to take AG and FC, because I already knew those were equal. That's from given. And I'm going to add to both of those. I'm going to add GF to both of them. What allows me to add GF to both of them? Well, technically, that's the addition property of equality. What allows me to call AG plus GF AF? What allows me to call FC plus GF GC? That's the segment addition postulate. Not very, what am I going to try to say? Not very easy to use that one because it requires kind of some extra algebra steps in it, which is kind of a mess. But there was a lot of these in homework, and there was a lot of these on earlier quizzes and tests. I always groan when I see one coming, but they're out there, so there you go. And then I'm all ready to go. You can read this forwards if you want later, but you know me, I always do my proofs kind of front to back, or sorry, back to front, and try to sew up the gap in between. All right, I hit page. Oh, it's a fade. Ooh, did you see that? Did you like that? Ooh, look at that. And then so complete this one. This is just oh, you can't see it. I'll show that up for you. See. Okay. Complete the proof. PQRS is a rectangle. That's a huge piece of information. Not only is it a parallelogram and the 19 facts that come with that, but I've also got right angles in it. And PT is, what's that little thing? PT is congruent to QV. Now, I can't really mark rectangle stuff on there. I can say stuff like this because it's a rectangle. Angle P is 90. Angle RQV is 90. That's over here. I'm just going to say definition of rectangle. That's nice. Wow, this pen doesn't write fast. Angle. It must be really painful to watch. Sorry. Okay. PS is congruent to QR. PS is congruent to QR. Well, this thing was a rectangle. These little things right here, these are just opposite sides of the rectangle. Namely, they are opposite sides of a parallelogram. So that's why. And I believe that's 5-1. Here's me accidentally memorizing the book somewhere. Great. PTS. Oh yeah, from what's marked already there, I have side, angle, side. Complete. Yay! Now, PTS, this little thing, and this little thing. They are parts. They're corresponding parts of congruent triangles. Why then would ST be parallel to RV? Well, I just marked these. The flow of this proof is very easy to follow. I just marked those in, and I'm saying, ooh, well, why are those parallel? Well, the angles we just marked were corresponding angles. And those, since those corresponding angles are congruent, they tell us that the lines are parallel. ST is now congruent to RV. Whoa, slow down. How come those, just because they're parallel, why are they congruent? Well, I already knew I had a rectangle here, which means this thing had to be a parallelogram, which means PQ had to be parallel to SR. Meaning if I drew that in, I'd know this is a parallelogram. I know opposite sides. Oh, wait, there's a way easier to do this. ST and RV were part of this. Yeah, big dummy. I'll just say CPCTC. See, I didn't follow that because it wasn't right afterwards. It's a lot easier if it's right after that. Okay, fine. Would have liked to go, this is 5, this is 6, this is 7. That's why sometimes it's easier to cross the whole thing out and do it your own way, and it's hard to follow someone else's logic. But, okay, they're not wrong. They're just not the way I would have predicted to do it. So now, okay, they just said this is congruent to this. Now we're getting at the fact that TVRS is a parallelogram. I was going to do that to get 7. All right, now it's a parallelogram because look at the stuff I just did. These last two things, I got a side that are parallel, a pair of sides that are parallel and congruent. That's what I called opposite sides. One pair theorem, which is 5 accidentally memorized. I hope you're accidentally memorizing the book too. It's not a bad feature. Okay, quadrilateral ABCD has the given vertices as points. Blah blah blah. All right, A is at 0. You know what? You don't need to watch me do this. Bam! There you go. Okay, so I'm guessing you know how to do that. If not, check these. Plot the points against a figure. Yeah, I did that. Okay. J is the midpoint of AB. All right, and K is the midpoint of BC. Whoa. So J is somewhere around in here. Would it be right? I mean, you can kind of look at this and go, yeah, it's kind of like diagonally that. That's how far that would have to be. I'm not sure it's exactly that coordinate, but I'm pretty darn close. And K, well, why didn't they just say J and K? Why did they have to tell me it was called J and K? Midpoint of B to C is probably somewhere right around here. Now, you can just about eyeball this one. It's not that bad. But to be really sure, the midpoint of those two coordinates, which goes right here, is halfway between 0 and 4. Yes, that's 2. 0 plus 4 divided by 2. And halfway between -1 and 3. That would be -1 plus 3, which is 2, divided by 2 is 1. Then guess what? It looks like it's really right there. And these two, I obliterated that there, sorry. The midpoint of that is what goes down here. So halfway between 10 and 8 is 9. And halfway between 1 and -3, if I add those up and divide by 2, should be negative. What? CD? What am I talking about? You guys got to stop me before I do something dumb like that. All right. BC. Okay, BC is from here to here. I'm looking at that midpoint. Okay. Halfway between 4 and 10 is 7. And halfway between 3 and 1 is 2. All right, good. And it kind of looks like 7 too. All right, great. I saw a negative over there. What am I talking about? It's getting too late at night. All right, 2 videos in 1 day is enough. Construct the altitude. Oh, I need altitude. I need construction tools. Just alright, well there's my trusty tools, but then I just realized I've only got 40 seconds left in this video, and I'm not going to be able to do the whole thing. But, because it may be a while before I do the next video, I'll just talk you through it in the next 30 seconds. The way this is going to work is we're going from Q to FP, and that has to be an altitude. So I need a perpendicular that goes from Q out here, and it's perpendicular. So the first thing you do is you extend that, and then you worry about trying to make this perpendicular here. Well, the only way you can get perpendicular is to do a football construction, to bisect something. So I need a segment that's sort of centered here, so that when I football it, it's going to go through Q. The way to do that is to start at Q and swing an arc and it's going to hit here and here, and then I football that. All right, time to go. I will hopefully see you in the next part.